Hello everyone, and welcome to this session on networking for cloud computing. In the next few minutes, we'll explore how data centers form the backbone of the cloud, how their networks are designed, what kind of traffic they carry, and the challenges providers face. Along the way, we'll connect these ideas to real-world examples from industry, including some from India. Introduction to data centers. The internet you use every day, Google Search, Gmail, Netflix, or Flipkart, all depend on data centers. Some data centers are service-focused, like Google and Facebook, that mainly provide online services. Others are resource-focused, like AWS or Microsoft Azure, which rent out infrastructure to customers. Data centers are also ranked in tiers from I to 4. Tier 1 is basic with limited uptime, while Tier 4 offers maximum redundancy and nearly 100% uptime. Example: AWS data centers in Mumbai are Tier 4, designed to keep even banks and government workloads online at all times. From server rooms to modern data centers, in the early days, companies just used server rooms with backup systems. But today, data centers look more like digital fortresses, spread over hundreds of acres. They use virtualization and automation to ensure maximum uptime. Example: Reliance Jio and Bharti Airtel operate massive data centers in India to support millions of mobile subscribers and cloud services. Classical data center architectures. There are two important traditional models: multi-tier architecture and cluster architecture. Multi-tier architecture. Applications are split into web, application, and database layers, used in ERP or e-commerce apps like Amazon or Flipkart. Advantage: even if a web server is hacked, the database remains secure. Cluster architecture. Groups of servers work in parallel for high-performance computing, used in industries like finance and entertainment. Example: Pixar uses clusters to render animated movies. In India, ISRO uses clusters for satellite simulations. Cloud-enabled data centers, CEDCs. Modern data centers are cloud-enabled, meaning they don't just virtualize servers but also manage workloads intelligently. They integrate IaaS plus PaaS and use orchestration tools like Kubernetes. Example: Infosys and TCS in India deploy hybrid cloud data centers where workloads move automatically based on demand. Physical organization and cooling: servers are stacked in racks, arranged in aisles. Some providers even use shipping containers filled with 1,000 plus servers for portability. But heat is a big issue. Cooling is critical. Google has experimented with seawater cooling in Finland. Microsoft tested underwater data centers. In India, CtrlS Datacenters in Hyderabad use innovative cooling to achieve world-class energy efficiency. Networking inside data centers. A modern data center has 4 types of networks: client, server, server, storage, management network. Topology matters too. 2-tier networks are simple but less scalable. Spine leaf topologies are now common for hyperscale cloud providers like AWS and Azure. Example: Flipkart's cloud infra relies on spine leaf networking to manage millions of product searches per second. Cooling and energy efficiency. Data centers consume massive amounts of electricity. Companies now design cold aisle/hot aisle containment for airflow. Indian companies like Sifi Technologies and NTT India focus on green data centers, using renewable energy for sustainability. Nature of data center traffic. Unlike the internet, data center traffic has its own pattern. Mice flows, 5 megabytes large transfers, like Netflix streaming or OS updates. Example: BookMyShow experiences huge elephant flows during ticket launches for blockbuster Bollywood movies. Networking challenges in data centers. There are 3 key challenges: availability, performance, security. Availability. Downtime means big losses. Providers use replication and multi-region failover. Example: Netflix ensures uptime by replicating data across multiple AWS regions. Performance. Cloud networks need low latency and burst tolerance. Traditional TCP/IP is often not efficient enough. Example. Microsoft Azure uses RDMA over Ethernet for ultra-low latency connections. Security. Data theft, insider attacks, and accidental deletion are major threats. Measures. Encryption, role-based access control, intrusion detection. Example. Microsoft 365 in India uses strong tenant isolation and complies with RBI and GDPR standards. Summary. So, to wrap up, data centers are the digital backbone of cloud computing. Architectures. Multitier for ERP/e-commerce, cluster for HPC. Cloud-enabled data centers add automation and orchestration. Traffic patterns are mice, cat, and elephant flows. Main challenges: availability, performance, and security. Real-world practices show how companies in India and worldwide, from Netflix to BookMyShow, from AWS to CtrlS Hyderabad, design their cloud networks to be fast, reliable, and secure.